So, XOR game. So we are given a positive number k. We need to find a minimum value of positive integer n such that XOR of n and n plus 1 is equal to k. If no such n exists, then print minus 1. So basically we will be given a positive number as our input, and we need to find a value n such that the consecutive, that is n and n plus 1, n XOR n plus 1 will give us a value equal to k. So here k equal to 3. So whenever k is equal to 3, so whenever k is equal to 3, so we can just start checking from 0 to 3. Okay, is 0, that is, this is I. Okay, so from I is equal to 0 to 3, we can just check whether I XOR I plus 1 is equal to k. So we can check whether 0 XOR 1 is equal to 3. No. So next value 1 XOR 2 equal to 3. Yes. Yes, this is 0 1 in binary form, and 1 is 1 0. So when we do XOR, 1 0 0 is 1 1 0 0 1. So XOR means like this is the value of XOR. This will be XOR if we are having x, y, and x XOR y. So if x is 1, y is 1, x XOR y is 0. If x is 0, y is 0, then still x XOR y is 0. For all other cases, x XOR y is 1. So we have 1 0 and 0 1 in this case. So if we do XOR, like we can do this XOR is 1 and this XOR is 1 and this is 1 plus 2 equal to 3. So the answer for the first one will be 1, because we need to print that n, here in this case y. So now let's check k is equal to 6. So if we check k is equal to 6, okay, so if we take k is equal to 6, so same way we can just start from 0 to 6. Okay, is 0 XOR 1 equal to 6? No. Is 1 XOR 2 equal to 6? No. Is 2 XOR 3 is equal to 6? No. Is 3 XOR 4 is equal to 6? No. We can just prove like by just taking this binary and just finding the XOR. If you can see that it will not be 1. Is 4 XOR 5. Let's take this 4 XOR 5 and let's 0 0 0 1, and this is 4. Okay, and 1 0 1, this is 5. If we do XOR, 1 XOR 1, as I told, like terms XOR will be 0, like term XOR will be 0. 0 XOR 1 is 1. So this is just 1, it's not 0, and still we can just go for 5 XOR 6. Still no use. We can just simply also just check 6 or 7, because what if it's 6? So still, so in this case, that like we need to print minus 1. Now another case that we need to consider is when k is equal to 1. When k is equal to 1, we need to say 2, because as per our algorithm, like what we are doing, we are just taking from 0 to k, but here our k is 1. So as per our algorithm, like we will be just taking 0 XOR 1. Is there any value? No. 1 XOR 2, is it is equal to k? No, it was equal to 3. But we cannot say like it's not a problem, because it's there is no 1. We cannot just return -1, because we just need to print if there is any n such that. So there is actually such n. 2 XOR 3 is actually 1, and in this case we need to give the answer as 2, yeah. So here 2 is 1 0 and 3 is 1 1, and when we do XOR like terms, this becomes 0 0 XOR 1, this one. So we are getting, it says 1. So 2 XOR 3, that is 2 XOR 3 is equal to 1. So our n is equal to 2, and this has to be returned. So this our edge case, the base case that we need to check. So if k is equal to 1, we can just return 2. Otherwise we can just say for int I is equal to 1, or we can also check from 0, I less than or equal to k, I plus plus, if, or say int XOR is equal to I XOR I plus 1, if XOR is equal to k, we can just return I. Otherwise, if we get out of this loop successfully, that means we haven't found any value for n such that n XOR n plus 1 is equal to k. So we can just return -1. Let's check. Okay, it's fine. But if we submit, it's running. Yeah, okay. So it's passed. So this is for the problem XOR games. This is pretty straightforward. And here just the time complexity is big of k, but here k will be from 1 to 100. So the maximum, the worst will be big of 100, which is still a constant. So big of 1 will be our runtime complexity, time complexity. And for space, like we are not making use of any extra space, so the space will be big of